Director of Civil Infrastructure for Mind Foundry. And our presentation is split into 3 parts, and each of us will take one of those parts, and I will start off talking about our digital custodianship vision. Again, John, if you take us to the next slide. So what I wanted to say to start off with is that we believe this vision is widely applicable, but ultimately that will be for you to decide, for you to judge whether it's applicable across the sectors and the asset classes that you are interested in. But what we're going to do in this presentation is focus just so that it feels a little bit more coherent. The examples that we're going to use are predominantly drawn from infrastructure and bridge engineering specifically. Okay, John, if you take us to the next slide. Around the world, we're confronting a major challenge. In mature economies, our infrastructure is aging, and at the same time, the expectations placed upon it are increasing. And together, that means that we need to manage that aging infrastructure effectively, and we need to do that in an effective way so that safety risks are mitigated and that we don't have loss of service. Okay, if we move on to the next slide, the fundamental questions around managing aging infrastructure in many ways are quite simple. You know, the questions we need to answer in asset management are simply to say, what is the right intervention? What's the right time to make that intervention? And how do we build and present a compelling case for the funding to undertake that intervention? But as so often, simple questions don't have simple answers, or at least in this case, it is not straightforward to arrive at good answers to these questions. Again, John, if we take us to the next slide. When I think back over my career, and I think back, 20, 25 years ago, it was very common that I would encounter those responsible for the management and maintenance of assets, engineers responsible for those functions, to have spent long periods of time looking after particular portfolios of assets, that they often embodied a true sense of custodianship in looking after those assets. And that long-term engagement brought with it a number of attributes that were really beneficial. That continuity of knowledge through that long-term involvement, that really rich, in-depth understanding of those assets that meant that monitoring could be timely, that interventions could be proactive, that there was a real sense through that spirit of custodianship around achieving long-term sustainability for that portfolio of assets, that those individuals would understand the users of those assets. They would understand the consequences if they were compromised in some fashion. So they would have a real understanding of the stakeholders and the communities that were affected, and provide a stewardship function over that. And they would also look across portfolios of assets so that they could understand how to prioritize where to focus their efforts. And I think what we've seen in many areas over the last 10, 20 years is that we've lost some of those attributes. We've moved to a situation where contracts for undertaking this work sometimes create a degree of fragmentation. Sometimes they bring a more transactional rather than strategic emphasis. And when I talk to senior leaders within the infrastructure sector in particular about this, I always get quite a lot of nodding heads when I'm talking about this, and they recognize that we've lost something. We've lost something over the last 10, 20, 25 years. What we've been thinking about is how we can recapture that, how we can recreate those attributes that are so valuable, but recognize that we're not going to do that in a manner which is to return to the ways of working of some decades past. That's simply not going to happen. John, if you move to the next slide, the opportunities that we've been exploring around how we can recapture some of those attributes of custodianship through digital technologies and digital tools. And that's where the partnership and the conversations that we've been having, the work that we've been doing with Mind Foundry has been really, really exciting, because we've been blending the domain knowledge, hands-on experience that we have with WSP with the really cutting edge technology, AI expertise within Mind Foundry. And what we've been looking to do is to think about how we can do things differently. So John, if we move to the next slide, move from a place where instead of going out and inspecting assets, we actually move to a world where we are imaging them, drawing analogs with medical imaging, for example. But then again, if you move on, John, to complement that imaging of our assets with really targeted sensing to understand performance data and performance characteristics. And again, moving on, one of the big deficiencies we have with the way in which we gather data, typically through inspection of existing assets at the moment, is whilst they tell us something about the current state of condition, actually those data sets tell us almost nothing of value that enable us to quantify the rate of change. And when you're trying to make those decisions about what intervention to take and when, really understanding rate of change is absolutely fundamental. And then thinking that if we're gathering this data at an asset level, what can we do to aggregate that across populations so we learn not just from individual assets, but from those data sets across families of assets and portfolio of assets? And if we can aggregate that data, again, if we move on, John, how can we use machine learning algorithms to really identify hidden patterns and trends, and then ultimately to enable us, again, if we move on, John, ultimately to build models that enable us to do better diagnosis and prediction so that can inform our decision making. And so when we talk about a vision for digital custodianship, again, John, if you just move on one slide, I guess this is that vision, is the vision that says that in the past, there were attributes of custodianship that we valued, that we recognize that to some extent, although lots of good things have happened in this world in this asset management arena over the past couple of decades, we've lost something. And our challenge has been to say, how can we regather, how can we recapture this? And that is the vision, if you like, that we've been looking to explore, looking to realize in that partnership with Mind Foundry. And again, if you move on, John, one more slide. So Mind Foundry is an Oxford University spin-out company founded by two leading academics in the AI world, and really doing some really exciting work that Tom will talk about later. And I think when you're trying to find ways to transform things that we do, it's so important to build these kind of partnerships that we're really excited about, that, as I said earlier, blends the domain knowledge that we have in the sectors in which we operate at WSP with that really specialist cutting edge technology expertise that resides within Mind Foundry. And John, if we just move to the final of my slides, I really like this diagram as a representation for what we're trying to do. At the heart of asset management is those decisions around intervention. And in order to get to good decisions, what do we need to do? We need to gather good data through low-cost monitoring and inspection, accurately understanding condition, understanding rates of change and deterioration, establishing maintenance needs. And then what we're excited about is not just doing that, as the left-hand diagram, a left-hand element of this diagram indicates, at a single asset level, but then actually to integrate those data sets, use those as training data sets at a portfolio level that unlocks all of those possibilities around machine learning and forecasting, everything that follows from that. But in my experience, actually, when you're trying to do things differently, when you're trying to achieve some degree of transformation, you need to recognize two things. The first is that you need to have a really clear and compelling vision for where you want to get to, but you also have to understand that you get there in small steps. And so what we're doing is we're taking small steps along this journey, small steps that our colleagues who are involved in inspecting bridges day to day have said are the ones that are most important. And fundamentally, if we're looking at following this journey, following this diagram, then the right place to start has got to be around data. And data in this context means inspections. And John and I and colleagues have been on a mission to challenge the status quo around the way in which we undertake inspections now for several years. And I want to hand over to John to talk a little bit about that before then he hands over to Tom to talk about some of the technologies that are being built to realize this vision for digital custodianship. So John, over to you.
Thank you, Steve. Yeah, so we're going to pick up on the bottom left-hand side of this diagram with asset inspections. And asset inspections are something that we've been thinking about now and researching for over a decade. We've got dozens of papers and we've put through 3 PhDs on the topic. And that puts us in a great place to innovate and to move forward with the way in which we deliver asset inspections. But before we look at that, I think it's worth looking back at why we do asset inspections in the first place. And really that comes down to 3 things. It's understanding what we've got, what condition it is in, and then making those decisions. So 3 decisions that Steve talked about: the type and timing of interventions and deciding on funding. And when we look at inspections, you might ask, we've been doing this for so long, why is change desirable? Well, the current techniques that we use are costly, they can be disruptive to our networks, and they can put our people in harm's way. But over and above that, they actually don't necessarily give us the information we need to make those decisions. They can give us subjective information, and they make it very difficult to understand the rate of change over time. And in terms of the decisions that we need to take, getting that timely information to understand the condition and forecast future performance is even more important as our stocks of structures are aging. So what have we found out? Well, in all of that research that we've done across several of the sub-activities that make up bridge inspection, we've explored and we've proven new technologies that are exciting. And when we take all that together, it feels like we're on the cusp of a transformation. And what's really, really exciting is that through our partnerships with Mind Foundry and our collaboration with clients, we're really excited to see these research ideas becoming a commercial reality. And so now I'm going to hand over to Tom Bartley, who's going to show you where we're at with making these a reality.
That's brilliant. Thank you so much, John. So as Steve said, I work at a company called Mind Foundry. We are an Oxford University spin-out with about 100 of us now, about 10 years old, and 60 of our people have PhD or equivalents in computer science, machine learning, data science, etc. And so it's as Steve said, it's great. We bring a whole lot of like the mathematics and the computer science to this, but our work with WSP on this topic really brings that domain expertise. And these 2 things together are really where we're starting to see the possibilities for what's going to come. So John, if you can just go to the next slide, please. I'm going to try and make this tangible in this section and show you some of the technologies that we've actually been developing and in the last few weeks I actually started putting into the world with WSP inspectors. The platform is called Windward. It's our response to the digital custodianship vision. And as Steve said, what we're trying to balance is this long-term outcome around better decision making with short-term benefits and really kind of how do we marry the kind of the need to start with data. We're actually in a very data poor sector, and whilst there's been 15, 20 years of digitization of inspection records, what we find, as John said, is that they're not very quantified, and there's a lot of inconsistency in that data. So John, the next slide, I'm just going to talk you through the Windward platform, which has 3 different products within it, and kind of show you some of the nifty features that we've developed to make inspections and monitoring more effective, and then talk about a research project that we're working on together to transform that data into decision making. So we'll start with Windward Inspect. Windward Inspect, slide please, John, is, as it sounds, an inspection tool. It's a mobile phone application that engineers can take out onto site, and it serves two purposes. One is better condition data, quantifiable, actionable information about the structure and its condition. But the other is just driving efficiency and making it a no-brainer that this is the right tool to use to replace existing workflows. So on the next slide, we have a kind of a quick demo of how that works. And so what we found when we were looking at how inspections are currently undertaken, and particularly digital attempts to digitize the inspection process, it's very much a forms-based approach. So typically someone will have to go out and fill out loads of data and attach some photos to that. But as Steve said, imaging is the key thing. And so what we've taken the approach of a camera first application. So the inspector can go out and take photos and assign information to those photos, defect type, severity, extent, all the information they would do, but we do it in an intuitive way. And ultimately, it's about capturing the overall condition of the asset and the specific instances of defects, so that we can do the kind of thing that starts to happen on the left-hand side of the screen, which is around starting to objectively measure and tell the computer this is what one of those things looks like for later machine learning processes, but using that as a byproduct of the inspection process. One of the nifty things we can do on the next slide is to show, oh sorry, no, we're gonna, there is about understanding there's kind of two aspects to this. So where is the defect is a really important question. Firstly, if you're bringing 200 photos back from an inspection that's done manually, just trying to sift that in the office and try and put that into a PDF report or upload it into the asset management system can be a hugely manual exercise. But ultimately, knowing where on the asset a defect is located is really important to understanding its severity. And so we do lots of different techniques to understand where is this defect on the asset. So the first is where is it in the world. The next is where is it located on the element, and you saw some of that in the demo previously. And then thirdly is where is that structurally located. And with those three things, we can start to automate the integration into asset management systems, the reporting, but we can also create a virtual environment where asset engineers can start to go in and understand what's actually happening with their asset in a much more intuitive way. There's some little features on there, such as real-time image quality checks. We were out on site last week with some engineers, and one of the chaps was saying it keeps saying there's glare on the photo, and what it was his lens was dirty, and it was just a really nice example of if once he cleaned his lens, the quality of the images came back better, and to understand what's going on. And there's no real scope to go back and take those photos again. So too dark, too bright, blurry, it just captures that and nudges the inspector to collect better data as they go. But quantification is the key thing that we've talked about. And so on the next slide, we've got an example of how we measure defects. There in the photo is a calibration target. That's just a checkerboard. It allows us to start to measure directly from photos. So by using that, we can register the photo against the world. But not only that, we can go into historic photos, pull them out of the asset management system. The computer vision automatically registers those images together so that you can measure historic photos over time. So if you didn't capture all the metrics you needed on site, either because you were in a rush or you didn't realize you needed to take that measurement specifically, you can do that back in the office. But also, you didn't realize there was something you wanted to measure 5 years ago, you can't go back in time, but with this functionality, you can. This leads us on to, and John's slide, please, the Windward monitor tool that we're working in. So what we've heard is that, okay, so we do inspections, but then sometimes there are specific things we want to track. We're really concerned about this. We're looking at these quarterly or even more frequently. And again, we think that information is very visual. And so Windward Monitor is all about understanding how we can quantify deterioration and change over time. The next slide, we can work with 3 different modalities that we're using. So the first is high quality cameras to get really high resolution photos, to maybe big lenses to take photos from a distance. Drones are, we've not mentioned them today, but obviously becoming more and more prevalent in the industry as a way of collecting capture data. And with kind of highway assets and railway assets, actually just ground level driven surveys collecting huge volumes of data. The challenge with these latter two is just the volumes of data that's produced, and then the need to go through them and extract those insights. And so what we're doing with those latter two is doing automatic image matching technology where you can take defects that you know that you're concerned about, go and take your remotely captured information. The computer vision is automatically matching the defects that you care about with the footage that's captured, so that we can do what's on the next slide, which is starting to visualize and quantify change over time. So we've seen these two bits of spalling before. They were photos taken of the same bridge several months apart. We've automatically registered them together. We've drawn a bounding box. The computer vision has automatically detected this is the area that we care about. And ultimately, we can say that this has grown by 11% between those two inspections. Getting to these volumetrics is going to be really important as we start to think about how do we use quantified rates of change and deterioration models, which brings us on to the final piece, Windward Manage. John, slide please, thank you. Where we're really starting to close the that infinity diagram, which is on the next slide again, John, please. Where we've been focusing on the bottom left here, so low cost, reducing the cost of doing inspections, perhaps reducing the frequency by which we need to do inspections because we've got better confidence in the lower risk categories, accurate condition information, starting to do some deterioration modeling. But where we really want to get to is a point where the AI and the ML is really bringing that round. So we're recommending the maintenance needs for an asset and helping an owner that's got thousands of assets to prioritize those needs between them, using the asset level stuff as training data that comes around into kind of the portfolio level insight. The next slide, please, John. The challenge with this is where we have this AI digital custodian that's making recommendations. There's kind of there's a huge leap of faith, or kind of a huge assumption that we can get this right. And so we were delighted this year to be selected for funding by ARIA, the Advanced Research and Invention Agency. That's a UK government research body that funds what they call kind of really big ideas that would take a lot of work to come to fruition, but they solve a really important problem for the world. And so it's modeled on the DARPA model, if you're familiar with that in the States. But we've been selected for funding, and the kind of the key risk here is that, and on the next slide we've got a little example, that when you think about the variability and the kind of the rate at which different assets that might seem very similar change, and there's multi criteria that go into like what actually makes a bridge reach a point of failure. That's a really complicated thing to do, and when traditional machine learning AI approaches are based on training data, if that training data doesn't have enough instances of that thing occurring, there's a risk that it misses it. And on the next click, please, John. We're talking about a really high stake situation here, whereby 99.9% model accuracy. If you're predicting how many people are going to turn up to the cinema next week, and that's how you plan your film scheduling, that's more than sufficient. If we're deciding the load-bearing capacity of a structure, or whether we make one intervention over another, 1 in 1,000 isn't enough. And so on the next slide, the ARIA project is all about funding the work towards verified, safeguarded AI systems. So, and it's giving us the headspace to really go deep in both the role that the digital custodian will take as a decision making, the different types of risks and decisions that need to be managed, but also to come up with what they call a curriculum of problems, to quantify, to be able to build these systems that mean we can trust the outputs, and there's the safety rails put in place so that the recommendations that are taken forward can be trusted. It's a long-term project. We're 3 months into the first 15 months of the phase one, and we expect this to come to fruition probably in the 27-28 timeframe. But it all starts with data. So we started with the inspections. We've got these low-cost, valuable interventions that we can make now. That all becomes training data that allows us to get to the stage where we bring an AI into the team as part of the team to help with decision making. So John, my final slide here before I hand back to Steve. And so that's our approach to start getting into that digital custodianship piece. It's as Steve said, it's a vision as much as it is or it's actually it's far more a vision than it is a product at this stage. And we're really keen to get your feedback. So Steve, thank you very much.
Tom, thank you very much for that. So we now have time for questions, and we've got some great questions that are coming in already. So if you have further questions, do please share those, and we really hope that that's been interesting for you. I'd like to start. There's a question that I think is a nice place to start. It says, isn't there a risk that if using imaging to quantify asset degradation and then we forecast future condition based on loss over time, the rate of loss could be taken as linear, and this could lead to over-optimistic results? I don't, I think what for me is really interesting about that question is that actually it acknowledges the centrality of understanding rate of change of condition to our decision making, and I think that is so important, and there's just been a real lack of understanding of just how central that is to our decision making, and it sort of fascinates me that if I think around bridge inspections in the UK alone, then I estimate that we spend something between 50 and 100 million pounds a year inspecting bridges, and yet the outcome is that we really don't understand rate of change of condition, and we're spending an awful lot of money but ending up in what Tom described as a relatively data poor environment. It really doesn't stack up. Now, in terms of making future predictions, actually what we're looking at is building data sets that enable us to be able to understand where we sit in a deterioration cycle, and where you've got those good data sets, then firstly it enables us to train and understand the way in which deterioration actually progresses. And one of the big nervousnesses we have around the situation with aging infrastructure is that we're very likely to be sitting in a place where deterioration profiles are on the cusp of being significantly nonlinear. And so your point about nonlinearity is absolutely right. But our approach doesn't need to be as simple as just projecting a linear behavior. In fact, just the other day, Tom and I were talking around how it's rather likely that a Bayesian philosophy is going to be appropriate here, where we start off with a prior deterioration curve, but then we're using real data to then use that to update our priors to get better projections for the future. John, do you want to add anything into that? And then I'll move us on to another question.
No, and I think, just on that kind of deterioration curve approach, I think what we've seen in existing systems is that you either take a linear approach, you take one based on expert judgment, or you take one based on the data. And what we're looking at in the ARIA project is taking our existing engineering understanding in the science of how that deterioration happens. So is that chloride ingress? Is it loss of section through corrosion? It's the equations that underlie that, and that's our prior. And then we're using real-world inspection data to update that and increase our understanding through capture of information. So we're able to bring together the best of all three of those different ways of doing it, and to capture that point where change starts to happen quickly.
John, thanks for that. And I know your research, your PhD, it was when you were asking all of those questions about when to intervene, and actually, one of the things that we didn't talk about earlier in terms of timing and intervention is that actually there are a number of really quite effective interventions that there is only a window of time up until a certain point of degradation when you can apply them. And so if you let things drift for too long, it's not just that you've got to do more maintenance. Actually, some of those quite attractive approaches are closed to you because the condition of the structure has gone too far. So Tom, can I come to you with a question? It's about using existing asset information collected over many years in mixed formats. How can we take advantage of that? And I think as a preamble to that, some of the early work, and Mind Foundry and WSP have been working together in this area for sort of 4 or 5 years now, was in collaboration with National Highways, using their entire defect library data set as some of our training data set, thousands and thousands of images for some of the early work. But of course that was just using the image libraries. There are very big data sets out there. What are your thoughts on that question?
Thanks, Steve. I think it leads very cleanly on from the previous question, which is about understanding rates of change over time, and we can't just start with inspection data today. We do need to understand, and you said people that have been looking after these assets their whole life for a custodian, a digital custodian to work, we do have to understand and work with that historic data. So we're looking at the structured information that's in asset management systems, but we're also considering the unstructured information, that the kind of the nuance and the that's is captured really in text in reports most of the time. And so with large language models and kind of natural language processing, again, through the ARIA project, we're eating a lot with this project, but considering how this historic information can come in, so that when we start to, data fidelity increases at whatever point we start to digitize with quantified inspections, we've already got really strong understanding of how the asset's performing. We don't know, but it's absolutely crucial.
Thanks, Tom. John, we've had a question about, would this work with third-party thermal mini cameras attached to a smartphone? And I think, again, we've taken some steps in this direction, but one of the things that I think is just really exciting is that, we've talked about imaging and using cameras to build data sets, but of course we do have, other techniques, thermal imaging, the traditional measurements that we do around chlorides, half cell potentials, these kind of things. And we didn't talk about it within the Met Core presentation, but actually layering up these data sets so that you can either visually overlay them and gain insights as experts looking at those images seems exciting, but also that we have the potential then to use all of those as training data into the machine learning models. But what are your thoughts on that?
Yeah, I think that's exactly right. I think, and correct me if I'm wrong, Tom, Windward, as it is, can already work with any camera that you can pair with your smartphone. So I think it would pull through by connection with 360 cameras, for example. And I can't see any reason you wouldn't be able to do that with thermal imaging. And to answer your point, Steve, I think you're absolutely right that this is where the custodianship piece comes in, is being able to not just allow our models and the understanding of the asset to grow as it would if an engineer was sitting through reading every single report and getting an understanding. So when we're updating that knowledge of the deterioration models, if there are chloride testing results, then that allows you to update some of those priors of where we are in the deterioration profile. So absolutely, it's about pulling all the information together to give us the best sort of view forward of the asset.
And I do think it's interesting, this analog that I touched on very briefly, of just thinking that the way in which we do inspections today has parallels with the way in which medical stuff was done many years ago. But of course, medical imaging has completely changed. That you have experts in imaging, you have AI supported tools that do preliminary diagnosis, and then things get elevated to consultants and other experts. In an inspection world, why aren't we thinking in the same way that we have, that rather than sending out experts wet, cold environments, often at night if you're on a transport network, to inspect things, why don't we have specialists in imaging, have AI supported tools to triage and analyze those images, and then of course we can then elevate concerns to experts that can then virtually inspect the structure rather than having to physically be there, knowing that you can always go out and take a proper look if you need to afterwards. Fantastic. So look, there was a good question here. Again, something that we've talked about, the three of us and with others many times, about links to existing asset management solutions, because as we all know, most of our asset-rich clients have very mature asset management systems, and it would be unrealistic to think that we could usurp those, particularly in this area where we're looking to do certain things differently. So, Tom, would you like to kind of come in on that?
Yes, I think Mind Foundry's commercial strategy is not to replace those asset management systems. I think they are they serve lots of purposes actually. From being kind of a document management system, John, we've been exploring how portfolio level analytics in terms of long-term cost forecasting is a different question to specific asset decision making and kind of prioritizing the work bank itself. And so there's lots of functions that are served very well by asset management systems currently. I think there's a lot of scope to kind of bring that intelligence in there as well. And so from a product commercial strategy, our view is that we'll interface with them and provide an intelligence layer on top. But I think the concept of digital custodianship is not something that's proprietary to the work that we're doing at Mind Foundry. It's very much kind of a thinking about how we can transform and embrace these emerging technologies in a broader sense.
Yeah, Tom, I think that's a really good point. I'm pleased you brought it up because you and I have talked in the public previously around this idea of digital custodianship, and actually one of the points we've tried to emphasize is that we don't view this as being a proprietary thing. We actually, we've invited others to kind of join us in thinking about this and whether it's useful in their domains of activity, and we've had some very, very fruitful and interesting conversations as a result of that. And I think we extend the same invitation to anyone listening to this webinar that if this concept of digital custodianship is interesting to you, if you think we've got some of this right or you think we've got some of this wrong, then we'd love to hear from you. And you'll see on the screen now there's a vision paper that we've put together that spells out in a little bit more detail some of the things that we've talked about today. And we've put this out into the public domain because we'd like to stimulate some debate. And we do feel that those attributes of custodianship, that something has been lost. We do passionately believe that some of these valuable attributes can be recovered through digital technologies, and we do believe that there are elements of the way in which you manage assets today that are really ripe for some disruption, and we're very keen to contribute to that because we believe that that's going to lead to better outcomes for asset owners, and ultimately, and most importantly, better outcomes for the users of those assets, the public society at large. So let's have a look. We've only got a few more minutes left. So where should we go? Could this work for managing water and wastewater treatment plant assets? The person asking that question is going to be a domain expert in that space. So if what we've said today sounds interesting, exciting, reach out. Let's have that conversation. Our belief is that these concepts are more wide-ranging. We're passionate about that belief of understanding rate of change, about having good data sets, that then enable machine learning to then be used to be able to create algorithms that will then support decision making. If that resonates with you in that domain, then we'd love to have those conversations. Where else should we go? There's a question around needing to have lots of sequential photos to build models. Can we use individual photos? I guess it depends a little bit. I suppose, Tom, again, I'll come to you in a second on this, but I guess what we're trying to do is to take those incremental steps, and I suppose this is the fundamental strategy. Take incremental steps, each of which provides a benefit in its own right, but also takes us towards that broader vision. And so that so what I've seen with the work is that we've been doing is that simple things around just being able to take measurements from photos in a really convenient manner is useful on an individual photo basis. For me, I get really excited when we get into that rate of change space, and I get really excited with the stuff that we've been working on, where you can take photos taken at different times in different light conditions from different angles, and then do clever things to them so that we can actually overlay them and get valid quantified rates of change data by looking at how those defects have changed over time. But what are your thoughts? How do you want to respond to that?
Yes. I think the challenge, John, and we've looked at this, and Steve, yeah, you mentioned working with highways data with tens of that is not just the photo. The image itself doesn't contain, from a machine learning perspective, doesn't contain very much information, and so where the kind of the tension that we have to work with is how well, what we the technical term labeled, the data is, and so how can we attribute historic information in a way that makes sense? And so at this stage, what we're trying to do is build these really rich labeled data sets, and the Windward Inspect app helps support building those data sets that we can work more with historic photos. But I think there's lots of dimensions to this, and there's lots of layers to it. The more that we can, we're at the start of this journey, the more that we can mine historic information and have models that understand what it's looking at when it looks at that information, so it can bring it into these individual, we use the word model again, but these individual deterioration models for at the element, the structure, the portfolio level. We'll start to build that up. That's a really rich, long program that we'll work towards.
But now, you know, for the specific example of the measuring dimensions from an image, all you need is one image today that has the target in sight. And then if you have photos of that same location from back in time, if you have that one image from today with the target in, you can then use that to, you can align the photos and register the photos from back in time and measure from them. So you literally from today, you can do the measurement with just one image. And if you happen to have historic photos, you can measure them too, which is, I think, is amazing. It's just magic.
And perhaps one final comment from me, so we're about to run out of time, but I think what Tom, you were talking about the importance of high quality labeled data sets. And, you know, one of the things that we saw really early on actually in this work, using data sets around, you know, we had hundreds and hundreds and hundreds of images of rust on bridges. And that you'd look at it and think, well, that's a really rich training data set. So we can train an AI to be able to understand that these are the characteristics of rust. So you have a photo, and it says it's got rust on it, and then you train the AI on that. What turned out to happen was that most of those instances were metallic elements, and they were metallic elements often near joints, and where there were joints, there were bolts. And actually what the AI ended up doing was thinking that when it saw a bolt, that was what we meant by rust, because on all the photos we showed it that says this is rust, it had a bolt on it. And that's one of the risks with AI. I think one of the really important things is that we understand the strengths and also the weaknesses. You know, and again, one of the really nice pieces of work that Mind Foundry did was actually to be able to pick out the pixels that were most influential in the determination of what it thought it was seeing. And actually the activity of doing that meant that we realized quite quickly that there was an issue, and that we need to tackle that in different ways. And I know that, you know, even that piece of work was a few years ago now, and things have advanced very, very significantly since then. But look, I can see that we're at time, so we should wrap up. So thank you to everyone who's participated in the webinar. I hope that that's been interesting and useful, and as a minimum, I hope it's been at least a bit thought-provoking. And as we said earlier, if these concepts around digital custodianship, this vision that we've got, if that resonates with you, then we'd love to hear from you. I'd love you to kind of join us on the exploration of these concepts, and and we're really excited about what we think the future here can look like. And if you're similarly excited, then we'd love you to come and participate in this conversation and this work together. So thank you to everyone for participating. Thank you for those who posted questions. It's great to receive those. Really, really grateful for that. And I think we should probably stop there. So on behalf of Tom, John, thank you again for participating, and I hope that that's been an enjoyable session.